In order to build this artwork here, which is based on a few inspirations that I found in the AGO, the Art Gallery of Ontario, we finally need to talk about rendering. For that, I decided to use Karma XPU, which is now officially in beta as of Houdini 19.5, and I think it's coming along nicely and is slowly creeping in as my render engine of choice in Houdini. Currently, I'm still figuring out a driver issue with my GPUs, so what we're going to witness here is a rendering using Karma XPU purely running on a CPU, which is good news for people on a laptop who might mostly rely on their CPU's power for rendering. In order to get this prepped for rendering, I need a few things on my lines here, and I need to create a bit of geo and a few shaders. So let's dive in here. This is what we created last tutorial. In this merge here, we've got those tangent lines and the orthogonal lines coming in here. The first thing I want to do is color those lines. And I'll do so by creating a color attribute called capital C and D. And in this case, I want to color each line that originated from one single particle in a separate color. And for that, we need to find out which points in this geometry belong to which lines. We can do so by dropping down a connectivity, which on each point here will store an attribute called class, which is an integer, and which is an individual number assigned to each primitive here. So if we look at the geo spreadsheet here, we can see that under class, we can now sort those individual points in regards to which lines and connected lines they belong to. And I'm going to use this class attribute to assign a different color to each of those individual lines. And for that, the first thing I want to do is use an attrib remap to take in this class attribute, let's just spell it out here, and remap it into another attribute. Let's say call it color value or colval for short. And what I want to do now is hit compute range. And this looks at the values stored in the original class attribute, which range from 0 to 1411. However, I want to remap those to be in the range between 0 and 1. So down here in the output max, I'll just input 1. And what I can now do is attach a color node here. And keep in mind that if you change your geometry here, you will have to change this input maximum here or hit compute range again and then set the output max to 1 again. However, if I have done that, in the color node down here, let's set the color type to ramp from attribute here. And let's zoom out a bit, set the attribute to colval. Now you can already see we are getting this shading here. And now I can change the palette here to, I don't know, something more garish or whatever you like in order to color those lines. In my case, I manually created a ramp here by switching this down here and making sure that each of those points here is set to be of constant interpolation like this. So now I can just dial in these constant colors here. And I drop down, I think, 5 points in here and set them up to be a dark gray, maybe like this, a light gray, something like this. I think it's white and not a light gray. Then a reddish color, something I think a bit like this. A teal or greenish color, something like this, and finally a blue, also a bit desaturated, somewhere in between here, maybe 190, something like this. And then I spent endless hours or minutes or seconds of actually dialing in where those points sit, just until I had something that I really liked. And you can experiment with this, again, totally to your liking. So that's the color on those points. However, later for rendering, I need 3 more attributes on here, which I'm going to use in the shader later. One is the tangent of those lines, and the tangent is just a vector stored on each point that points to the direction of the line. And I can easily calculate that using a resample node again, attaching this to the color, making sure I uncheck maximum segment length. I don't want to resample those lines, I just want to use it to, if I scroll this down here, calculate a tangent attribute. And let's call this just tangent and not tangent u. And that just takes care of calculating and storing that vector on each point of the direction into which this line is pointing. Now finally, 2 more attributes we need for rendering. One just to tell apart those lines from the rest of our geometry, and then another one storing the diameter or the width of those individual lines, both of which can be created using an attrib create node attached to the resample node. And in here, I want to create 2 attributes here. Let's call one width. It's a point attribute, a float, that is fine. And down here, I want to set its value to 0.0075. Again, lots of experimentation. When I prepared the setup, this looked fine for me. The second attribute I want to create, let's call it lines, and let's set it to 1 for those lines here, like this. Okay, now my lines are done, and I can shade those, but I also want the underlying solid geometry, and for that, I'm gonna go up here to my tangent field, and let's use a merge here, and wire in that tangent field here into the merge. Let's also maybe hold down Alt and click in here in the connection line to set just this connection point so we're not getting too much of a spaghetti salad here when we drag this down here. And maybe add another of those intermediate points, again Alt clicking on here and then I'll drag over this merge node here and merge it with those lines here. And if I highlight it now, I get both the underlying geometry with the tangent field and these lines here. For the underlying geometry, I also want to use a color node to give this a color. In this case, just a solid color. And let's set this to a reddish orange, maybe a hue of 24. And then just slightly desaturate it, something like this. If I visualize those attributes on this color node here, I can see those incoming 4 fields from my tangent node arriving here. However, also for shading, I want to just rename the tangent field, which is field 0 that we used, to be called tangent and not field 0. Let's do that using an attribute rename, which will wire in between the color and the merge. And let's rename the field 0 attribute to tangent, so that we have similar as on the lines here, which have this tangent attribute. Now after the attribute rename, we also have a tangent attribute here on this underlying surface. And finally, similarly to what we've done before at vecting the points, I want to use an attribute blur to take this tangent field and blur it out, smooth it out by dropping down this attribute blur node here, unchecking pin border points, and in the attributes I'll just select tangent field here and blur that for 16 iterations like so. Alright, just for good practice, let's attach a null to this here, call this one out in all caps, and now let's talk about shading. For shading and rendering, we're gonna switch Houdini's layout to Solaris, and we're not gonna bother much about Solaris and the USD finesses built in there. We're just gonna use it in a very straightforward and lazy way. Welcome to motion graphics. So in here, the first thing I wanna do is import my geometry that I want to render. In this case, I'll use a sub import, and then point this to the out node that I just created, which lives under obj, geo, and if I click on here, it shows me the out node here. Let's hit accept, and after a bit of thinking, we can see in the viewport this geometry coming in here. Also, over here, I've got the scene graph, and from sub import, if I click that down here, I can check the surface, and over here in this window, if I drag the name over, we can see a few attributes coming through here. For example, the normals, the point positions, but also the class that I created or the display color. And that's one of the weird things when importing Houdini geometry into Solaris for rendering, that default Houdini names such as CD for color diffuse automatically get renamed, in this case to display color with a capital C. So keep that in mind. And also UVs become renamed into ST, I think. However, the width and the tangent come over pretty much unchanged, and also the lines attribute comes over unchanged. So that's all working. The usual way I progress from here is attaching a material library in which we will set up and assign materials. And then for this case, let's go easy by just using an HDR. So I'll attach a dome light into which I'll load an HDRI momentarily. And then let's create a camera by just control clicking on this camera icon up here. And that automatically creates a camera at the viewport position and locks the viewport to the camera. So I can now tumble the camera just by tumbling the viewport. If I don't want that, I'll uncheck this lock here. Right, finally, let's drop down Karma render settings, which will allow us to dial in, well, the settings of our render engine. All right, if I want to see what we are rendering now, before I want to do that, I want to switch my rendering engine to XPU, which is a bit faster, even if it's only using the CPU and no GPUs. So if I want to see what we set up here, I will switch my perspective viewport from Houdini GL to Karma. And after a few seconds of initialization, we can see this is rendering here. And you can see I've got a bunch of graphics cards here, which are trying to be initialized here and which then fail. Again, this is a driver issue I'm currently having, but it doesn't matter as my CPU is still running and rendering with this. Few things here. The first thing that becomes apparent is that we have these outline selections here. And you can set up your viewport and the display on this sidebar here, which we can also scroll down here. So for example, to display or hide the selection outlines, we can enable or disable this one. Also in this case, I want to get rid of this symbol, this icon here for my lights, which is this here. And let's also get rid of the background grid, which is up here again and hides here. So now we've got a clean viewport and we can add a dome light here. So on the dome light node here, let's just drag this down until we see under the base properties tab the texture slot, and I can select a texture here, for example the previously selected HDRI I had here, or you can just open up your file window on this here and then just select a file. Just make sure you uncheck show sequences as one entry. Alright, immediately you can see my viewport changed here, and now I'm rendering this using the HDR I just selected and loaded in here. However, the shading does not look right to me, so let's work on that. Also, before we start on the shading and the Karma render settings, let's just under the limit tabs here, increase the diffuse limit to maybe 4 bounces and also the reflection limit to maybe 8, because this image here will mainly rely on reflections. And now we are making sure that all of the reflections render correctly. All right. let's dive into our material library. And in here, I want to work mainly with MaterialX nodes because Karma XPU is, well, based on MaterialX, and those shaders and nodes work really reliably. As of Houdini 19.5, if I right-click in here and select MaterialX, you can see we have this MaterialX subnet, which we could use to build a shader in here. And in here, you will only be able to display the MaterialX nodes and a few utility nodes here. In this case, it's a bit disadvantageous as I need one node that is not listed under the MaterialX or globals, which is the USD prim bar reader. So instead of working in this subnet here, let's go up one level, delete it, and build our shader here on the standard material library. The center core of our shader will be the MaterialX standard shader. So if I start typing MTL and then standard or SDA, I will be greeted with this, and let's drop down the shader. This is this node here, which I want to apply to the whole geometry here, which I could either do by dragging and dropping this on here, but in this case I want to just go up one level and assign it directly on the material library node here by dragging this down and checking assign to geometry. And in the geometry path, I want to assign this to all of the geometry's primitives. That means all of the geometry's meshes coming in here. Now I want to select the material BOP I want to assign, which is when I select stage and material library, this MaterialX standard surface. So I'll hit accept here, and now the shader is assigned here, and everything looks white. Let's change that by going into the material library again, and on this shader, let's continue building. First, let's just check if the shader has been assigned correctly by just changing the base color to something, maybe yellow, and we can see, yes, our rendering changes as well. The first thing I want to do is use those colors we set up in our OBJ context to drive the base color here. And for that, I'll need the USD prim bar reader. That's this node here, which I'll drop down in my shader editor here. And I want to import a vector, which got renamed when we imported this surface from CD to display color here, this. So let's type in here display color with a capital C, like this. And then let's wire this into the base color slot here, and we can now see those colors coming over. Next, let's work on the overall look of this shader here and make it look a bit more reflective, like a gold or bronze or copper metal, which we can do by increasing the metalness. In my case, a value of 0.7 worked nicely for me. And then let's dial in the reflection a bit further in the specular tab here. And in here, what I did is I increased the index of refraction to 10 and also played around with the specular roughness a bit. And I settled on driving this roughness by an attribute stored on our geometry that's coming in here. Namely, I want to drive this depending if we have a line or if we have the underlying geometry. And if you remember, on this geometry here, we've got an incoming attribute called lines, which is only set to be 1 on those lines and 0 on the other geometry. So let's import this one by again using a prim bar reader here, this time to read in a float called lines. And then let's remap this. By now it's 0 on the underlying geometry and 1 on the lines. And in my case, I wanted to change that to be 0.4, so really rough, similar to what I dialed in here on the underlying geometry, and a bit less rough on the individual lines. And I'll be using a remap node, a MaterialX remap node that is, into which I'll wire the prim bar reader's output, and then in here the input low and high are set correctly, 0 on the underlying geometry, 1 on the lines, and I want to remap this to be 0.4 on the underlying geometry and 0.1 on those lines. And this output here, I want to wire in my specular roughness, like this. And now I can see those lines have become a bit more reflective, a bit more specular, while the background surface stays rough. Also, on our MaterialX standard surface shader, let's try what happens if we increase the specular anisotropy just slightly or maybe drastically, and we can see that results in those rendering errors. That is because for anisotropy to work, Karma needs an information in which direction this surface is running. It needs its tangents. Luckily, we created the tangents and renamed them to tangent. So for the shader to have those accessible, again, let's use another prim bar reader, which we will drop down here. So again, prim bar. Drop this down here, and we're going to read in a vector, which is called tangent, which we set up on our incoming geometry, and we're going to wire this into the shader's tangent slot like this. And now I can see this anisotropy being rendered correctly. Now let's set this anisotropy up a bit. Again, you can see by increasing or decreasing this value here, the anisotropy gets more pronounced or less pronounced. And again, I want to drive that anisotropy depending on if we have the underlying surface or those lines here, which I can do by again taking the lines attribute and remapping it. So I'll just take this MaterialX remap that I already set up, copy and paste it down here, and set it up so that when the value is 0, so when we are working on the underlying geometry, we have an anisotropy value of 0.85, and I don't want to have any anisotropy on those lines here, so I'm going to set that to 0. like this. And now let's zoom in here a bit, drag this over, and let's wire in this output here into the Specular Anisotropy slot here, like that. And if I'm not sure if this viewport has updated correctly, what I can do is go here to Karma Perspective and hit Restart Render. And now I can see this is the look I was going for, with the anisotropy coming through in the underlying surface, and the lines just being specular without anisotropy, like this. One last thing, I want to add a bit of bump here, just breaking up the uniformity and smoothness of the underlying surface. And I want to set up a procedural bump just using a MaterialX noise. And that is a bit complicated, I found, and cumbersome. So let's go through it. What I need, let's start from the end and work this to the beginning. So I want to create a normal map. So for that, I need a MaterialX normal map node, which is this one here. And this output goes into the normal slot of our MaterialX shader like this. As an input, I want to use a noise value that only outputs values between 0 for here my surface is very low and 1 for here my surface is bulging out a bit. And to be able to feed those singular values into a normal map, I need to convert them using a MaterialX height to normal. That's this node here. So that takes in a float value and outputs a normal vector. So let's wire this into the normal maps input like this. And now let's finally use a noise to generate those values coming in here. MaterialX noise 3D is what I used. And this output goes into the height to normals input. Now finally, for this normal map to work, we will need to feed it the original geometry's normal as well, which can be accessed using the MaterialX normal node, which is this one, which just outputs the surface normal or the shading normal at the point we're rendering. So let's wire this into the MaterialX's normal maps normal like this. Not too much to see yet, a bit of a distorted anisotropy reflection here. If we just cut this here, if we disable the bump, we can see we are changing our shading, but I want to be able to dial in the size and the scale of that noise. So first, for the scale of that noise, in the MaterialX noise itself, I can dial back the amplitude here, which I did drastically to 0.003. So it's only very slight variation in height here. But also there is no slider with which I can change the scale of that noise. And for that, I need to take our shading position and multiply that with some number, which I can then use to scale this noise here. So let's do that by importing the MaterialX position and then multiplying this using a MaterialX multiply, and then wiring in the position into the first slot and the output into the MaterialX noises position in here. And now what I can do on this multiply node here is, for example, increase the multiplication on the X and Y axis to drag out this noise just in one direction. And if we increase the amplitude now, we can see this is the underlying noise we created. Again, as for the strength of this noise, this bump map, in my case, I wanted to go for something rather small, so it only comes through very subtle. Let's go for 0.05 or 0.03. And that's the shader here. So most of this, to me, after having used it a few times, is pretty straightforward. Just keep in mind you need to use the USD primbar import, the primbar reader, to be able to import geometry attributes, some of which have been renamed, for example, the CD into display color. The only thing I found cumbersome is this whole tree here that I had to build to be able to do a simple bump map. But once you have it, you can either wrap it up or just memorize it. It's just a handful for a normal bump map. All right, so far. Let's, before we finally render this, add a sort of backdrop. So let's go up again one level. And in here, let's, instead of using a SOP import, use a SOP create, which allows me to dive in there and then use your standard SOP nodes to create geometry. In this case, I want to drop down and use a grid first, which I'll set up to have a few more rows and columns. I went by 40 by 40. And then I used a bend to just bend this into a cyclorama. And in the bend SOP, let's just scroll down here. I hit set capture region. And then if I scroll up again, bend this by 90 degrees. And finally, to make this bend a bit more smoother and not so tight, I increased the capture length to 4, like this. Let me check anything else. Yes, the capture origin, I moved forward by -1 unit, so we have this cyclorama here. All right, back to our stage here. So on our stage, I want to first shade this cyclorama that I created, again using a material library attached to it, and maybe let's wire this into our dome light here. And then we can see this sits awkwardly in our scene, so let's move it around by adding another node, the transform node. And the transform node, just as the standard transforms in your geocontext, allow me to rotate this thing. And now my viewport isn't updating, so let's just restart this rendering here. And I think I'll have to exchange those primitives just with all the primitives coming in through here. And now I'm able to correctly rotate this whole thing here. I rotated it to 100 degrees along the y-axis like this, and then moved it down by minus 0.07 units, so it sits down a bit. Okay, before I start shading that background, let's merge it with our sculpture here, so we can see both in our render window by just adding a merge node in between them, just merging both geometry streams. So I'll merge in my sculpture with the Cyclo and then feed that into the rendering pipeline with the dome light here. And I might need to translate this backdrop here a bit further along the x-axis and also maybe set the transform order to rotate transform scale. And then I also scale this up by 4 units like so. All right, let's switch to our selection handle here, and that's our frame that we are rendering. So let's finally start shading that backdrop here. Again, by selecting our material library, checking assign to geometry in here, assigning this to all geometry primitives, and then in the material library, as previously, just using a MaterialX standard shader, the standard surface here, and on the stage here, make sure that we are selecting this material VOP, so that's the material library 2, a MaterialX standard surface, like this. Let's hit accept here. Let's reset the rendering. Let's restart it again. And to fix this black backdrop, which clearly isn't what I set up in the shader, let's rename the material in here, because what's happening here is the material matching in this version has a bug, and it tries to match this shader that I created in here to this backdrop that I created here. So in the material library 2, instead of having that the same name as our other material, let's just call it BG for background. And now the color comes through. So I want to set this up to have a really dark black color. Let's set a value of 0.07 like this. Let's increase the diffuse roughness to 0.5 a bit. And then on the specular tab, let's just dial back the specular to be 0 like this. And that's all there is for this background material. The only thing that I did was I think I increased the light intensity on our dome light here to be of intensity 1.5 and then transformed this a bit so it's rotated by minus 20 degrees so the light hits this sculpture at a bit of a better angle. And that is it. The only thing I want to do, or I can do, is increase my path tracing samples. In this case, for my final rendering, I set this to 1024 samples and then let this converge. And if it's converged, the real quick version of saving this out here is using this button here, Save Current Renderer Image, which saves this as the image that we rendered here in this resolution, 1280 by 720. And I then can just select an output folder and call this, I don't know, render_output 001.png, and Houdini will automatically make sure that it's saved as a PNG. You could also write .exr, .jpeg, any of the supported file formats of Houdini. Then hit accept, and that just saved out this rendering. And that was the really quick and dirty, really basic way of how I render out quick-ish renders of objects that I create, procedural setups we create. And I think Karma XPU now is at a point where it's suitable for most of my daily needs. Not the absolute exotic ones, that might still be a case for Karma CPU, but I think we can see the enormous progress that XPU is making with each successive version of Houdini. Of course, what you always want to do is now after rendering, run this image through some sort of comp, post-processing, adding a bit of color correction, but I'll leave that up to you. Now, if you're intrigued about all these intricacies in Houdini, want to learn more, or maybe just plainly support us, consider becoming a patron of ours, as it is through the help of our patrons that we are able to keep Entagma running. And to anyone out there already supporting us, thanks so much. With a very special thank you going out to Important Looking Pirates, Jellyfish Pictures, The Mill, Method Studios, Electric Theater, Pixonic, Random42, Rodeo Effects, Side Effects, Lusion, Styleframe, and Refeka Nadol Studio. Thanks so much. And finally, as always, if you create any artwork using this technique, just tag us, send us a link. We really love to see what you cook up. And until next time, as always, it's cheers and goodbye.